So thank you very much for coming, and we have a slight change in agenda today. The folks who could not present yesterday, they may present in the morning, but other than that, our agenda is same. We are really glad and honored to have Miss Ivy Hooks from Johnson. She has retired from Johnson Center, NASA Johnson Center as branch engineer, branch chief, but she's here as a keynote speaker. And I'll just say a couple of things that I know about her, and it's quite amazing to see her career development. She started at NASA Johnson Space Center in '63, and she was there till '84. She retired as I said, she retired as chief of flight software branch. There is a lot to learn from her, and she has also received tons of awards. A couple of them I'll mention here. She has received award for Space Shuttle Program Definition and Preliminary Design Team in 1972. She received an award on the NASA Skylab program in '74. And she received NASA's Exceptional Service Medal in 1981. I would invite Miss Ivy Hooks to come and present us for this keynote. Thank you very much.
Oh, goody, this is one of those I can barely see over. In my younger days, I would have...
You can walk if you want.
Oh, I can, okay. But then I can't see my notes. In my younger days, I would use a Coke box, but you don't know what those are. Yeah, I retired over 40 years ago from NASA. It's hard to believe it. How many, I know there's some NASA people here. Okay, put your hands up. Let me see where we are. Okay, a few, in a number of different centers. Do you have any JPLers here? None.
There's one.
One, okay.
So just to give you can use this laser if you want.
I'm not going to use it.
Oh, and then you can advance using this.
I'm not going to do any of that, just paper.
In that case, goodbye.
I have to tell you, I rarely accept anything that's at 8 o'clock in the morning. But nobody told me that. I guess I should have suspected when he said keynote that it would probably be early in the morning. It's not so bad because, of course, I got here ahead of the class a couple of days, so I could adapt to the time change a little. I'm very honored to be here with you. I cannot remember the last time I heard anybody say flight software until Ronnie called me up and said, we have this conference. It's a flight software conference. I'm like, okay. Used to be a term I heard every day. Flight software then was shuttle flight. For me, was the shuttle flight software. And so what I'm going to do a little bit today is to tell you about how that came about, a few things that happened, and give you a little bit of advice. Hopefully not too much advice, and I hope I've left plenty of time if you want to ask questions. Before you ask, I have never built any software. I once tried to build some software, a subroutine or two to use in a program at NASA, because I got so tired of having to call the computer division to modify the program when I wanted to create a different simulation. And I was simulating different spacecraft, and I had to put different rockets on them in different locations and things. And getting those subroutines built just took forever. Because first I had to get somebody in NASA to agree. Then they had to give it their contractor, and they were always changing programmers at the contractor. So it took forever. So one day I thought, I can read this Fortran code. This is not hard. I'm a mathematician. I can read this code. So I can write the code. That's basically what I do when I tell them I need something anyway. So I'll just write some new subroutines and add them. It wasn't very many hours before I turned that run in that I got a call that said, "What in the hell have you done to our software?" Nothing, I just added a few subroutines. Why? I said, "Because you typed too long." They said, "How did you do it?" I said, "I just wrote the Fortran code." "How did you add the new subroutines?" "Well, I just put them in there like the other subroutines." "Yeah. What about the little numbers up front? The A colon, B colon, and all that stuff?" I said, "Well, I didn't know what that was." So I just copied some other ones and stuck them in there. Of course, you can imagine that poor computer was going everywhere. But the message it kept putting out was something about you're missing something, or do something with something or other. I mean, it had an interesting message. It knew something was wrong. It was just the message it was putting out was not the right one. So that was my only attempt at coding any software. So writing requirements for it, I did that. Testing, and I did that. Managing the development of it, I did that. But I did not write software. So I don't know what role any of you play. How many of you are actually the software architects? Yeah, I would expect you would be. A lot of architects in the room. So good. We'll talk about those different things. Let's go back in history to 1969. Is there anybody who wasn't even born then? I was afraid of that. Oh, it's getting to where you bring up these dates and people just look at you like you're talking about something that happened in the Dark Ages. Okay, that was the year man first stepped on the moon. How many of you can remember that moment and seeing it on TV? Okay. Not the same ones who had their hands up before. There was a computer on board when we went to the moon. It had 512K memory. K. Remember those little disk thingies that we had? Floppy disk at one time with some of our earlier laptops. They were about that size. We went to the moon with that, which meant there wasn't a lot of flight software on the modules. But months before we landed on the moon, my career took a big turn. I had been working on advanced programs. What are we going to fly next? And so I was playing with all kinds of different things. On April Fool's Day, 1969, early in the morning, I received a call to go to building 36, third floor. Now, well, I checked the back of the phone book to check the map to make sure I knew where 36 was, but I was pretty sure it didn't have a third floor. You probably don't have phone books, right, anymore? Okay, so, phone book? What's a phone book? Must have a map somewhere. So it was a very auspicious date to get that phone call. I was told that Dr. Faget, who was head of engineering at JSC, to go there by a woman who said she was his secretary, or said her name and assumed I knew she was his secretary. When I got myself to the building, there were only 2 floors. But there was what we used to call a high bay, which is just a big test bay, and it was 3 stories tall, and there was a door going in down at the lower level, and I recognized some people going in and was pretty sure that nobody would pull an April Fool's joke on those people. So I decided I was probably safe to follow him in. We got in the building, went up the 3rd floor, wandered through a maze of hallways to a room, a number that we'd been given, walked into a virtually bare and terribly dirty room. There was enough mumbling for me to know all were responding to the same command. And then in walked Dr. Faget, carrying an airline garment bag. He walked in, unzipped the bag, opened it up. Would you hand me my bag? Reached in and pulled out the funniest looking balsa wood plane you have ever seen. It looked like this, but his wasn't mounted on anything. He pulled it out. His version was about this big. It was balsa wood, and he flew it across the room. It didn't fly well. Kind of did a dip-de-doo and then ran into all the pipes that were exposed in the ceiling. And he said, we're going to build America's next manned spacecraft. It's going to launch like a rocket and land like an airplane. That's kind of heady when you're about 28 years old and been working at the place less than 10 years, and you're sitting in a room of only at that time about 20 people. We got up to 28. The team that did the basic design for the space shuttle. Not that it didn't get redesigned 50,000 times in the next 3 years, but we did the basic stuff. In a room where there were 3 women and the rest men, another woman engineer and I, she's Dot Lee from the aerothermal group, and the secretary. And there was one telephone on the secretary's desk. And at that time, telephones didn't move around. You want to talk on that telephone, you talk at the secretary's desk, right? Because the headset was connected to the base, which was connected to a wire in the floor. So that was the environment to start to build the space shuttle. In that room, there was Dottie and a couple other folks from Aero and Aerothermal. There were people from structures, people for guidance and nav, people from, I wrote a bunch of these down because I can't even remember them all. Communications. Communications being flight to ground mainly, and also vehicle to vehicle. Propulsion, of course. Crew systems, that's things like the spacesuits and the toilet. Electrical and electronics, it's all the stuff that makes this whole spacecraft kind of run. Guidance and control. There was not a flight software organization. There were also no laptop computers or even a PC. We had mainframes that consumed punch cards that were created from those green programming sheets. Do they still have the green programming sheets? Anybody remember? Okay. You just work directly to the machine. Okay. There were no cell phones. Like I said, there was just that one phone. There was no internet. There was no Wi-Fi. No one but NASA in the military had rockets that could reach into space. It's been 40 years, folks. 50 years. That's a long time ago. Lots of things have changed very, very fast in our world. And I bet you still have the same problems in flight software we had then. Some things never change. For our very first spacecraft, Mercury, NASA at Langley, essentially, in Virginia, built the first one themselves. They built one. And then from that, they did a lot of testing and stuff and changed things, and they wrote the requirements and hired McDonnell Douglas to build one. Then they flew a bunch of unmanned flights. Then they put men aboard. Then we did suborbital flight. Then we did a few orbits. And then we finally had a real orbiting spacecraft with man aboard. And it was mostly analog. Switches, controls, more like an airplane. Displays were almost non-existent. There were many simulators, both manned and unmanned, on the ground to help us design, test the vehicle, and train the astronauts and the flight controllers. These were also heavily analog machines. My significant other said he can remember programming the first simulator to train the crew. And you pulled out the wires and plugged in the wires. The first time I ever walked into the the trainer area. It was probably during Apollo. And there were all those bundles of wires across the whole room, and with lots of wires sticking in. I never could figure out how they did that. How would you know where anything was? I mean, that stuff was hard compared to writing a few programs. Okay? Software wasn't new, but when we decided to build the shuttle, we were deciding to build the first fly-by-wire plane. Think about it. There were no every plane out there today is a fly-by-wire plane. There were no fly-by-wire planes. The military got one flying. How many military guys have I got in here? Or girls? Military? Nobody's owning up to being in the military in this whole room. The military built one and flew one before we did, but at that time there were none. And of course there were some senior members of staff who didn't think we could do that, since to them computers were horrifying. Fortunately, I was at NASA, so failure is not an option. So we stayed locked up for 7 months in secret. We couldn't tell you about what we were doing. Oh, that was lovely. Couldn't tell anybody what you were doing. Occasionally you had to call out to get somebody to get some data, run a simulation for you or something. But couldn't tell anybody what you were doing for those months. And we addressed many engineering and technical problems during that time. But still, no flight software. I was on the shuttle design team. I remained on the shuttle design team when we came out of the lockup as the shuttle separation integration manager. Does that sound like an oxymoron? Yes, it does. Initially, I just had to separate the boosters off. No, actually, I had to separate this from one that looked like this, but was a whole lot bigger. That was the booster. It looked just like this, blown up. We're going to put it here. The booster would launch us up to a certain point, and then it would quit and drop back down, land at the Cape, and this would go to orbit. There was no budget to do that. So then we had booster, we had solid rockets, then we had engines on here, and then we had an external tank to carry the propellants for that. So then I got to separate the rockets, and then I got to separate the tank. Those were pretty heady jobs, I can tell you. They were fun. They were hard. I'm sorry, I just like hard things. I mean, if it's not hard, anybody can do it, right? So a lot of software was involved in that because I did it all with software. I didn't want anybody trying to do it by hand. I mean, I can build software and test it and then go use it and it won't change. I can build something that humans can mess with and train them till I'm blue in the face, and then when I let them go, God knows what they're going to do. So I preferred the software. Then once I got it built, it would pretty much stay that way. Not always. There were a few circumstances where it didn't stay that way. So so then I got to separate the orbiter from the 747. That was the fun one. And software and flight software during this time was racing its ugly head. It was being developed by a different organization than the engineering division. It was being developed by something called the Data Systems and Analysis Group. We used to call a large portion of that the zoo in my years at NASA. But they had selected a special team to work on flight software. And we had taken the software away from Rockwell, who was the prime contractor, given it to IBM, and put it in Houston so we could micromanage it. So actually that worked pretty well. So I really did like the jobs on the design team and the things I came out there with. And probably because I'm definitely a systems person and I'm definitely a generalist. I do not like doing things to the 42nd decimal point. I just really don't care about all those numbers beyond. So anything they had that nobody else wanted to do, which is how I'd gotten to be on the design team in the first place, every job I had at NASA was usually given to me because some guy who sat in the cubicle next to me or something said, well, I don't know how to do that. I didn't do that in college. We weren't supposed to be doing things we did in college. We were doing things nobody had ever done before, for gosh sake. You know, get a life. So if they had things that nobody had done before, they'd tell me to go do them. So I just did it. About the time we were ready to do the approach and landing test at Edwards, I'd just about done all the design and analysis for the flight I could do that really needed me to be there anymore. I had this wonderful section that worked for me. And there were guys in it who knew how to take over everything, so I decided I needed to go do something else. So when the opportunity came along, I took a job as technical assistant to the center director. That is a very lofty title for a gopher, but anyway. It's where you got sent so you could learn about upper management, and upper management can learn about you. The center director threatened to keep me on board long after my 6 months, just because when he had me in a board meeting, the men would not curse. Do you know how much you have to bite your tongue? I know all those words. I can fling them around pretty well too, but I didn't do it, because if I didn't say anything, they didn't say anything. So kept them under control. When I looked at where I was going when I left there, I realized I couldn't go back. You really can't go home again. My section was doing great. They had a new section head. They were off taking care of all kinds of things. They'd done all the things they wanted to do that I would never let them. And that's when I realized the first thing I learned about management was I was over-managing some really great people. Ivy, why don't we do da-da-da? And I would say, I already did that. I already checked that out. Don't worry about it. But they were worrying about it. So as soon as I was out of sight, they did what they thought they needed to do. Fortunately, I was never proven wrong about anything, but they had to just prove it to themselves. And it's okay. Let them. I was just a little too hands-on. Anyway, I was working for Dr. Kraft, so I said, where am I going from here? I went over to Ops, interviewed with Gene Kranz. Everybody knows Gene Kranz from the Apollo movie. And George Abbey, who you may not know. God bless you, you're so lucky you don't have to know George Abbey. Anyway, and said, I'm thinking about where I'm going to go. Maybe I should think about coming to operations. And they said, we don't want you. I thought, somebody in personnel is turning over in their grave right now that you just said that to me. That was not what you were supposed to say. So it was probably Abby who said it. So Krantz tried to cover it up and say, well, it's like we like to get them younger than you are. And we like to get them and train them our own way. I said, okay. Fine, bye. I was not meant to be an ops person. And so that was all right. But we went to Kraft and said, where am I going? And he said, Ivy, in a few years, everything we do is going to be run by computers. And no matter what you're going to do, you have got to start understanding computers and software. So I think you ought to consider going to flight software. So I knew the division chief there because as Kraft's technical assistant, I got to arrange things for senior staff all the time. So I knew him, and he was a nice enough guy. And I said, Dr. Kraft told me I needed to know more about software, and maybe I should come over here. And he said, well, I need somebody to run level 6 and 7 verification for the shuttle. Well, I know what verification is, and I know how to do it. I've done it for some software we had. It wasn't any different than doing it for hardware, actually. So I said, okay, I can do that. I mean, I didn't have to do the work. IBM had to do that. But I had to approve it and check it out and make sure they were actually testing what we meant by the requirements, and maybe they had even built what we meant by the requirements, or not. But anyway, the flight software wasn't a total unknown. As that separation integration manager, I'd written lots of requirements for the flight software. And then I would get calls from people in ops who would say, IBM in programming your requirements right. They were keeping check every line of programming. And they tell me what was wrong, and then I have to go to the board and say, I have a problem with IBM, I have a problem with software, they're not doing it right. They weren't dumb. There was more than one way to interpret what was written. And they didn't know enough to know what it really meant. So, and during the ALT program, I had a wonderful time. On the very first flight of ALT, when the orbiter came off the 747, do you remember those flights? Anybody remember watching the orbiter come off the 747? Okay, couple. You probably remember watching the orbiter fly over here on the 747. They used to do, or wherever you were. We've gone nearly everywhere with that. Separation occurred immediately. The co-pilot called Big X on computer 2. Well, that meant the computer had failed. Wait a minute, we got multiple computers. They're supposed to work together. We landed fine. Everything was okay. And we'd simulated it thousands of times. Except we never simulated computer 2 failing. We'd only ever simulated computer 1 failing. Turned out that was a lot easier to do in both the shuttle avionics lab, in the shuttle mission simulator, and even in the IBM simulations. So the safety folks said, oh, they had a disaster. And I'm like, what do you mean? And then I find out the computer 2 that went off handled the controls, was the primary computer for handling the controls to the elements. So had a sensor failed somewhere else, or had the other computer not gotten the signal it was supposed to get, we would have been off, but we would have had no elevon. Real hard to fly any airplane without an elevon, especially a shuttle. It's nothing but elevon. So then I realized I didn't know how the computers interacted. When they told me they were redundant and da-da-da-da-da, I interpreted that as a certain thing. And they gave me more definitions, but it didn't ever conflict with what I had known. But what I had interpreted was wrong. Didn't work that well. And I didn't know that till we did that separation. Never saw it, never know. Nobody ever mentioned maybe you should fail some more computers, or do you understand when one fails what really happens to all this data? No, I didn't. I thought I did. That is probably the worst condition you can be in, is thinking you know something you don't know. Obviously, nobody else at NASA knew. Nobody knew. IBM knew, or really knew. Actually, what they didn't really understand is how an airplane flies, but so they wouldn't have noticed anyway. So that was pretty scary. So I decided that probably the flight software guys needed me, because they obviously were doing some crazy things. Okay. Another interesting thing I discovered when I got to flight software, we wrote things that we call discrepancy reports when something went wrong. Do people still write discrepancy reports or something very similar? Oh, that's what I thought. You still got to tell somebody who didn't work right. Over in the shuttle mission simulator, which was built by Singer Link and run by a different division, no matter what happened in the simulator that caused a discrepancy to be written, they would write it against the flight software. They didn't write it against the simulator software. Because if they wrote against flight software, IBM would figure out what was wrong, whether it was their software or the simulator, and tell the simulator guys where their problem was. So they just bypassed all that mess of writing against who they thought it was against and having them fight it because they didn't want to admit they had anything wrong. They just let IBM go track it all down, and we got things solved in half the time. You don't ever have that problem either still, do you? Yeah, that's what I thought. And my favorite was when the crew said, I said, why don't you just let that damn thing land itself? We made it self-landing. All thing you got to do, push that button for the gear to come down. I would have never made that manual, knowing how many gear up landings people have had. But they wanted some button to push that was really there, so we gave them the landing gear. And I want you to just do the full automatic landing. It doesn't work right. The software's not good. I said, what are you talking about? This is what he asked her. What are you talking? No, it doesn't work right. I said, it works perfectly fine. No, not in the simulator. I said, ta-da. Problem isn't the flight software. The problem is your simulator. No. Got to have hands on the stick. Go ahead. We let them. That was a big problem with software, building the flight software. Every time they would tell us they wanted something, then they would have to put something else new in the spacecraft to let the pilot do it himself, and then they would have to add something else to the ground system, so if the onboard system or the crew didn't do it right, the ground could do something. Every time they wrote a change, they said, why don't you just make it triplicate and pass it around, because that's what you do. We can't ever get autonomous, because you won't leave it alone. Somebody else has always got to be taken over. And so everything costs a whole lot more. And you have to verify a whole lot more. If you get it wrong, you have to fix a whole lot more. So more is not necessarily better, okay? When we got nearer to the approach and landing, except for that one problem, went real smoothly. And I was over working flight software by then, so. We were into level 7 verification. And they've done thousands of simulations. You know, our verification list was, jillion runs of computers and of multiple computers. Over in the SMS, the Shuttle Mission Training Simulator, they would, the crew would be doing it on IBM simulators where we did our basic verification. It was all automatic. Didn't turn the crew on. Didn't have a place for the crew to interfere. So I went over to an IBM presentation that was going through each requirement and each flight to show that they had simulated to show how things were going. I kind of snuck in, and they put this, obviously, slide up. And it's the elephant over the course of maybe 10 minutes of flight. And it's going bing, 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 it stops. And then they say, oh, we landed fine. Simulation was a success. Our software is working fine. I said, what? Go back to that slide. What is that? Well, it's the elephant. I said, you're not going to land with one. You're going to have knocking it off. It can't take you going, bing, 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 bing. And furthermore, the airplane doesn't do very well into that. Oh. Had guys building simulations, evaluating simulations, who had no idea how an airplane flew. And there were a lot of guys in the room. There were engineers that had no idea how an airplane flew, or what would happen if you did that really to elephants. You would be going like this, or just quit doing anything. Just keep going up one time and forget to ever come back down. So I was shocked. I was going, oh God, I got to sit through all this. I got to read all these slides because I can't trust them to tell me they were successful. They're not lying. They know that at the end of their simulation, the airplane came to the ground safely. But they didn't know that what they were simulating couldn't be right because the airplane shouldn't do that. And if it's doing it with our software, then it's what we got to fix. Since there isn't anything else moving it, it's pretty much our software. So that got fixed. I hung around a little longer after we got shuttle flying as head of the flight software branch. I really was getting tired of the whole thing, and one morning we had a flight, and I was head of that branch, and I was coming in about 10 minutes late to work. And when I walked in, the hall was packed in front of the door to my office. all the big IBM guys were there, and the honchos in my division and the honchos in the directorate were there, and they were all go around them, and nobody even says good morning. And I go into my office, and I said, what happened? Well, actually, I'd already heard on the radio. We had some kind of something funny they thought happened on the flight. And so they were running around, and all of them in a panic. You know, you have to understand at JSC after Apollo 13, everybody in the world wanted to be a hero. So they wanted something to go wrong that they could fix so they could be a hero. And our division chief had been one of those heroes in Apollo 13. That did not help. And he was good. He was really good. He was really smart. But he was hard to work for because, well, after I left, I finally went back and said, why did you treat me the way you did? And he said, because you didn't do things like I would. I said, if I did things like you would, one of us is redundant. Sorry. Another friend suggested that he was just getting even with his 8 sisters by picking on me. Could have been the truth, too. But everything I did really upset him. So I came in, looked at I heard what they said on the radio. I came in, and the guys told me what happened. I said, well, that's no big deal. That's just the jets are firing, and I don't know why they're firing so much right now, but they're firing, and that's the way it feels and smells and looks like when it doesn't, the control jet. I said, no, it's no big deal. Well, maybe the software messed up. Software doesn't mess up. That was supposed to happen. I mean, with what they were doing on board themselves, they actually were causing those jets to fire. And they were firing some of the larger ones. And if you're just basically running on software, we'll fire the little ones first. And if that doesn't do it, we'll fire the big ones because the big ones make a lot of noise and they are disrupting. And apparently that was going on in that flight. So they want you to take away all the simulations, stop everything, and go simulate this 10 times over to see if they could recreate the condition on the ground. I said, doesn't make any difference. Nothing's wrong. No, we got to recreate it. And of course, we got to stop everything everybody's normally doing today on the ground because we have to do this. I went and got my guy, one of my section heads. We had a very strict order of, if something goes wrong, IBM has to call. This person at NASA has to call. This person at NASA has to call. And I was second or third in that list. And my guy I said, you didn't call me. No, we didn't have cell phones. I said, you can call me. Well, I didn't want to bother you. So I decided I'd had enough of that gang. That's total disrespect. And I know it's because I was a woman. Well, too bad. He was a jerk, I can handle being a woman. And most people can put up with me being a woman. Putting up with a jerk is hard. So I decided I didn't need to be there anymore, so I went back over to work for the head of engineering for a while. And to do some other things useful in my career. And then I decided it was time to leave. When Fauché retired, I decided it's probably time for me to get out too. I wasn't eligible for retirement, but I could quit. So I did. After 20 years, I did not retire. I took out my measly amount of money I had put in over 20 years that they hadn't given me interest on, and took that out, invested it, and lost it. But anyway, I figured I could take care of myself anyway. I just couldn't find a place in NASA I could be anymore. It was mostly operations, and they were working on a space station. I found a space station the most boring thing in the whole world. It just gets up there and goes around and around and around. We put them up before. Most of them have stayed up, so I'm pretty sure we know how to do it. That just didn't look like fun. So I left, went to work for a small company supporting NASA for a few years. I did everything for them, including marketing. I'm also not a marketeer. Then I went to consulting. And I was in great demand initially because I had been in a lot of places in NASA. I'd gotten up fairly high, and the local aerospace companies were bidding on stuff for space station, and they couldn't understand the requirements they were getting. That never happens either, does it? So, but they needed to bid. And how do you bid on requirements you can't even read? So I went over to help them bid, and saw what a mess the requirements were. I was actually embarrassed that NASA had put anything out as bad as they did. And the requirements for space station, for software and things and simulator was just incredible. They were asking for computers that don't even exist, to do things that don't even exist yet at that time. So, oh dear, I don't think you're going to get that, guys, because I don't think NASA's in the business of developing computers for you. So, and I was working for some companies and trying to understand that were currently in jobs, like running the control center. And I would grab one of their programmers or whatever they were, designers, whatever, and I'd say, "What are you working on?" And she would tell me. And I would say, "What does it do?" "Well, I don't know." "Well, what does it affect?" "I don't know." "What does it interface with?" "I don't know." "How are you building?" Well, she thought she knew. I'd been through that thinking, I was pretty sure that wasn't going to be a pretty outcome. They didn't really know what they'd done in the past, and now they had no idea what they were being asked for in the future. So now I'm going to change topics a little bit to my favorite subject, which is requirements. Can you imagine having requirements as a favorite subject? Well, I'm a little weird. My problem is, when I see a problem, I like to fix it. I had a boss one time that told my new boss, "Watch her. You better keep her busy all the time. If you do not keep her busy all the time, she will go solve problems you don't even want looked at." So, because problems, supposed to fix it. So I saw requirements as a problem. I decided I probably could fix it. So I'd work systems, I'd work software, I'd work hardware, I'd work simulations, I'd work verification. All those required that you can understand and communicate requirements. I worked for practically, somewhere along the line of my career, I worked for practically every major aerospace firm before all the mergers. And of course, you guys have names all over the place I've never even heard of that are new ones. But there were ones back then. IBM, Ford, Aerospace, Lockheed Martin, Allied Signal, McDonnell Douglas. I worked for every NASA center and for the NASA Project Management School out here at Wallops. Other government agencies, Army, Navy, Air Force, Marines. I love working for the Marines. Sir. If you don't mind having sir shouted at you, they're a great class. I used to say I walk in, they have no necks, no hair, and they shouted, "Sir." You knew they were the Marines. I've worked with NOAA a great deal and FAA a great deal. And I've also taught for the Canadian military. I've also taught people as far away as Denmark. I've taught people who build software or write the requirements for the software for insurance, including USAA. Any of you retired military probably know about USAA. And a lot of other people that build insurance-y stuff that I didn't even know existed in this world. For grocery stores, HEB, a local Texas company that covers all of Texas and most of Mexico. In fact, I've helped cancel a few of their projects. They got a new manager of all their software, and he knew I had been coming in and doing training classes, and he invited me over to help out. He said, "I've got this program, we're working on this program." He didn't know what he's doing, and I don't know what he's doing it for. I said, "Well, you got a problem." So he said, "We got a lot of those." But we called the young man in, and I asked him some questions. What is this software going to do? He wasn't real sure about that. Who are you doing it for? He had no idea about that. It was one of those projects that get in the system and have been in there for years, and they're floating around, and finally one day they pop up, and they finally make it to the top of the heap, and you give it to somebody. Seen that happen? Not admitting that. Yeah, I got one. Yes, over here. I mean, you always got the queue full of jobs for software people. But nobody goes back and redoes the priorities on very often. So we sent the young man away, and I said, you might as well cancel it. It has no sponsor. You're spending money. Nobody's going to use it when it gets built. So, and if there's something in there that's really needed, somebody will come back and give you some new requirements. Don't worry about it. I've worked for a number of medical companies. That's truly amazing and scared the living tar out of me every time I've ever been sick since then. Abbott Labs, Bechdel Dixon, Tremulo. People that build software for accounting programs. And people building processes, because requirements for processes had to be done for accounting firms. I've worked on requirements to give the architects who were redesigning a church preschool area, my funnest group to work with. I've worked with Caterpillar in Minneapolis on hardware and software for the products that come out of there. My last class there, I had every VP in the company in the class. Because everybody else had already gone to class, and they said, you guys have to go. You're holding us up. You're messing us up. After class, a couple of them admitted they probably were part of the problem, which made the people that had pushed their bosses there considerably happier. I've worked for Kodak, Rockwell Collins, and a few I can't remember their names anymore, and some that I'm sure don't exist anymore. And it didn't matter whether I was working with them on systems or hardware systems or software systems or combination. They're complex, getting more complex. Everything you work on every day is more complex than what you worked on yesterday. It's because you can with software, folks. You just can't keep doing that to hardware. But you can with software. The more you give them, the more they want. Now, communications will determine which products are best. Best from the standpoint of you can build them faster, they require less rework, they cost less, and they don't fail. I've worked on exciting projects. I've worked with amazingly smart people. I've worked with some incredibly great managers. And some points I want to make are universal. Okay? Number one, everyone must know what is needed to know where this thing that you're working on will function, what it will function with, what it will interface with. If you're designing, the architect certainly must know, but you got to get that data to your designers and programmers. If they don't know the purpose and what the software they're to build is likely to do, likely they will make mistakes. They're not dumb. They just don't have the knowledge. So my favorite architect in the whole world said, give you this analogy. He said, this is a team approach to engineering, especially software. Keeping everybody in the loop, sharing information, and questioning each other is what makes the difference between success and failure. He said, I can write a requirement to tell a programmer to add A plus B and place it in C. And that programmer can do that. They can do it a dozen ways. But they'll probably pick the wrong way the first time unless they have all that other data. And you're going to have to do it over. Or later on, it's going to bite you. And they know when people work in the black world, that becomes a big issue because they're always trying to keep people having minimal information. But when you're building something that has to communicate with lots of other somethings, everybody needs to know what everybody's trying to do. And truly understand it. Now, I'm just about the most curious old lady you'll ever meet. I'm more like a kid. Why is it doing it? What's it doing? Why are you doing it? So I like to know all that stuff. But there are an awful lot of people out there who never question anything. They just say, okay, you told me to go add A and B and give you C. Probably not if C could be a 0 and C could ever be in the divisor in a way. That would not be good. But there are people who don't worry about that. So you have to worry about it by asking them questions, by giving them information, by sharing things, by making them feel a part of the team and making them really participate. Another thing is, as you're getting and establishing requirements, now I do not believe you can go do all this and not write down requirements. My company, I sold out to my partner, and he recently sold the company to an Austin company. And I really like the folks that run the company, and they do some great things in software. But the guy that runs it really doesn't think you have to write down requirements as long as everybody knows everything. How do you know they do if you don't get anything written down? Well, if they kind of understand, I said, no, not kind of understand. Kind of understanding is not enough. You got to write down those requirements, because some things you know about and think about aren't requirements. They will affect the requirements, but they're not a requirement. And we've got to do it. We've got to write these requirements down. And I'm going to tell you, when you write a requirement down, you must write down the rationale for it. Why? Sound like a 4-year-old. Why? Constantly. And what will happen is you'll either get the real why, or you'll find out you don't have a real requirement, or somewhere in there you might actually write the requirement when you try to write the why. And I have had people that I have known and worked with at NASA for years take a class and say, oh my God, I just did it. You said I was going to do it, and I did it. They were doing an exercise where they had to write requirements and rationale, and then they realized the rationale was their requirement. And that's not a large tome either. Tome is another good word for it. When you write rationale, it should be short and succinct. But I got so tired of hearing, I was working back with NASA again. They were trying to put a man on Mars. By the way, I vote totally against that. I am all for unmanned programs. They cost much less money, do great, fantastic things, give us all kinds of wonderful data. We shouldn't spend all that money trying to do things that people weren't meant to do. Now, that might not sound like a very nice thing to say coming out of Johnson, but it's just, there's no good reason. There was a good reason to go to the moon. We needed to beat the Russians, and we needed to know we were, as a country, could do it. There's really a good reason to go there. But we don't need to go to Mars. And nobody's going to like it when they get there. I mean, if you really feel like you need to be someplace like that, they got some places out in New Mexico and Arizona you can go romp around in the sand. So, let JPL keep landing things. Goddard keep sending things to run around the planet, but we don't need to go there anymore, people. So, I'm a fan of space programs. I'm not a fan of the manned space program. And now it's even a little bit woman space program, but not a lot still. Lord, they had women astronauts before they had women flight controllers. Anyway. So you get, I would say, why do you have this requirement? To go to Mars. I said, that's the purpose of the program. We're supposed to be talking about building a spacecraft. Oh, well, it's to build a spacecraft to go to Mars. I said, Why? Well, make the spacecraft fly? Why? Well, to make the engine fire. Why? Well, because the command button's pushed and something happened. I said, Command button's pushed, something has just happened at the same time, fire engine. Now that I can understand as a requirement, but not like bullshit you've just been giving me. So asking why will actually allow you to throw out 2/3 of the requirements that you get on a program. You don't need them. I found out with the Mars group, they thought they were going to come in and write requirements for a vehicle. I said, guys, we haven't even come up with the concept. You need a vehicle. Talk about a vehicle until you decide what you really want to do. What are you going to do at Mars when you get there? You're just going to fly there, jump out, jump back. I jumped out of the car one day so I could run over into Maine and get back in the car so I could say I'd been to Maine. Is that what we're going to do at Mars? Are we planning to sit there a little while? Or are we going to walk around like we did on the moon? What are you going to do when you get there? How many are going to go? Until you decide those things, you can't design a vehicle to get somebody there and back. Oh, well, we need this many diapers if we're gone that long. I said, I never care how many diapers. At some point, I will tell you how much storage space you have, and you're going to figure out what you can take. That's it. Kind of like in real life, you get to take, so many suitcases and they weigh under this. It's the way we're going to do it, boys and girls. I don't need your telling me how many space for how many diapers you need, for God's sake. It's not going to drive the design of the spacecraft. It was really fun. So I fell and broke my ankle. And while I was laying at the bottom of the stairs, and my feet's still up there, but I knew something wasn't right, but I was at the bottom, all I was thinking was, I don't have to go back and talk to that Mars much anymore. For months, I'm not going to have to see them. And I wasn't real thrilled about having a broken ankle, but it did solve that problem for a while. And then they would say, well, listen to you listen in our change port. And I did that once, and I didn't do that anymore. I've got one more point, and that's verification. Stating how I'm going to verify something can be very revealing. Asking what can happen if I don't verify it might also expose some unnecessary requirements. If you say, we don't have the money to verify that, then you don't need that. You can't have it. Maybe you can verify it at a higher level, so to only ask for it at a higher level. If you go around asking people to add 1 + 1 = 2, you're going to end up having to verify 1 and 1 is equal to 2. I don't want to do that, so I don't want to ask for that. Tell them to add A plus B and put it in C. But if you've got to tell them that. But for gosh sakes, don't give them requirements you don't have to. And those verification people have to be on your team from the beginning. For 2 reasons. They can find some really bad things you've got in the program early, even when it's still on paper, and nowhere else. And 2, if you don't make them a part of your team from day one, they will have problems later and mess things up for you really badly. So you might as well start with them and keep them in line the whole time. I thank you for having me. That concludes my speech.
Take some questions. Are there any questions for Ivy?
None? Oh, we do that.
Hi. So you mentioned at the beginning that there were 3 women on the program out of 20, and I see the ratio is similar or smaller here. Do you have any comments?
It's sad. I worked with a number of really bright women in my career at NASA, and I got to hire some and work with some that have now also retired. They're out there, and they're getting more. I have, at the moment, 5 great nieces and 1 great nephew in college. And since I'm helping all of them, I keep up with them. And I am driving everybody into engineering as much as possible, especially the girls. So I've had one of my cousin's daughters graduate from University of Alabama in electrical engineering. She's now doing robotics work for a German company, but that have offices in Austin. And as a matter of fact, this week she's in Germany. I have, I think, 3 others enrolled in various engineering schools and things. I have 2 at Texas A&M, and one of them is from here. The other one is from Texas. The one from here is also in the Corps. So I think the Navy's going to get her when she graduates, but that's okay. Still got her in the engineering field. So I'm promoting getting women in engineering every way I know how. I worked at NASA with a number of men who wanted me to talk to their daughters to see if I could talk them into it, because they didn't even know how to tell them that they could really do it, that you could really be in that field. I am named for a woman engineer, Dr. Ivy Parker. I always called her Aunt Ivy, but she wasn't really my aunt. She was my parents' best friend. So when I turned out to be a girl, not a boy, which my dad had planned on, they didn't have any girls' names, and so my great-grandfather said, you're going to have to name her Ivy Faye. That was Ivy for my Aunt Ivy and Faye for my mother. She was the first woman to graduate with a doctorate in organic chemistry from the University of Texas, and worked in the oil and gas industry her entire career. When registering for a conference like this, they would try to send her over to the spouses table, And, they said, go over to that table and get your stuff. That's for the ladies. She would say, I'm not a lady. And I encourage any of you who have opportunities to work with young people, and I mean starting in junior high, to encourage them to go into engineering, period. I still think if you got the skills, if you can learn the stuff it takes, which is the math and the physics, and apply them, then you can be great at somewhere in the field. Different people do well in different areas. I mean, like I said, I like those working things out to the nth detail. Once I kind of had it lined up here and handed over to somebody who liked to do that and let them take care of it. I was lucky for a lot of my career working for bosses who understood that and who didn't mind my doing that, and in fact found it kind of useful. And yeah, I was hoping I would see more women here this morning, but I'm not totally surprised.
Yeah, I'm very pro encouraging more women and people in general to enter this field, but are we maintaining an environment that women want to stay in?
Well, with the messes going on right now about sexual harassment, I look back on my career and my college days thinking I was in an all-male environment, and I survived that just fine. I mean, there are a few people picked on me a little bit. They didn't do it very long. I had the privilege of having 4 younger brothers. If you weren't pretty tough by the time you've grown up with 4 younger brothers, you're never going to make it anywhere. I wasn't at work at NASA 3 months before I was sitting at one of the drafting, they probably don't have those anymore, drafting tables up on a high stool, because I was told to do this plot, and everybody else gone off to lunch. And I was trying to do this plot. I wanted to do it at the draft table so I could use their electric eraser. I didn't have an electric eraser. I never used one again because I kept going through the paper. And paper was really a big deal. You had to go down to the secretary and tell her you'd ruin that sheet of paper to get another sheet of paper out. The cabinet unlocked the cabinet to give you a sheet of paper. It was a big deal. I was standing there working on this intently, and at one point we were in a new apartment building that had been moved into. They just moved NASA in it, so I could see the railing across and the pools down below, and people were standing out there. So I got off my stool, walked over, and looked down, and there was a little snake swimming around in the pool. Okay, so I went back and got back on my chair. And a little bit, somebody went, and I looked up, and there was this whole line of guys standing right here. And behind me, there were even more guys. I knew it was not good. And I said, yes. And they said, well, we've been here a while, and you haven't even noticed it. And I said, what's the big deal? And they said, well, have you checked what's on your table? Those things were monstrous. And up at the top, they had a computer printout paper. And somebody lifted it up, and there lay this nice little garter snake. And I did not go, ee! I went, maybe you should go put it back in the pool and quit playing. Now, that set my career at NASA. I did not get harassed a whole lot after that. Because if I had thrown that into that group of men who were over there, you would have heard a lot of ee's, I can guarantee. not scared of snakes. My mother told me when I screamed once, the snake's scarier of you than you are of it. Leave it alone. So I don't jump at those two. I hate cockroaches, but snakes don't bother me. If you do a few things right in the first 6 months or so, you can kind of set the way things are going to be in their work. I think we have such exciting work. One of the great nieces at A&M had an internship this summer over at the labs in Bethesda. And I kept checking on how she was doing. Then she got bitten by a mouse, and I went, whoops. Not a good plan. I said it wasn't a sick mouse. No, it's not a sick mouse. They're banging and making loud noises and then opening them up to look at their brains to see how they're taking it to study PSVD. Okay. So she had a wonderful summer doing that kind of thing. There is so much interesting work to be done. It's a matter of finding it. I don't know how the teaching of engineering is today. When I was in school, I spent most of my time in math and physics, and then I had a minor in chemistry and a minor in English. To say I've used the minor in English more than anything else would be true. But I had good and bad professors. You just have to get through good and bad professors. I don't think it matters what field you're in. How do you learn from the ones who can't teach? You have to figure out a way to do it. That's kind of life, I mean, you pay a whole lot more now than you used to for it, and it seems like it ought to be better, but I don't think it probably is. Intern programs, summer programs, co-op programs are such wonderful programs to try things. Does this fit me? Because one size doesn't fit all. And one size doesn't fit you forever. You may be getting tired of where you are. There are a million places you could be that could use your talent, that you could make a difference. The thing that I know of most people I know who really care about engineering, whether it's software or hardware, is they want to make a difference. Would that describe you? Yeah. You really care what goes on, and you want to make a difference. So, and then things like these conferences and other things that you can get in so you can learn from your peers all over the world, so you can share what you know with them. They're wonderful. No, I think engineering is just going to get better as a field, not worse. I mean, you might make a lot of things autonomous, but somewhere back there we still need this brain and the caring and the understanding. So that's what I think is going to happen. You may tell them about the books or get somebody ready to draw?
Yeah.
Okay.
So
I have a book that I published in 2000. It's called Customer-Centered Products. That's because the American Management Association, who published it, called everything customer-centered something that year. Bad marketing company, I'll say. The subtitle is Creating Successful Products Through Smart Requirements Management. And no matter what you're working on and what you do, I promise you'll find something useful.